Hello everyone. I hope you found yesterday's video and notes to be very helpful. As always, you can email me, let me know if you have any other questions or if you need anything else as well. So these are the answers to the assignment from yesterday. Feel free, you could forward through the video just to skip straight to the answer, but let it play obviously if you need to hear the explanations. So I'm going to go over these in detail. We have a couple examples that I'm going to show you how to complete the square to get the equations in that HK form in order to graph. We'll look at a couple ellipses already graphed and then have to write the equation from that as well. So this would conclude the lesson over ellipses when we're done with today's notes. All right, so let's take a look at 1A. This is the equation we were given. We want to identify the center, graph this, also write in the vertices. We can write them right on the graph. It makes it easier to understand what they are. And then also include the length of the major axis. So it's still always good to go over these little pieces because you never know in the end. I might give you some different information to help you graph it or find another missing piece. So looking at the numerators here, because we don't see any quantities in parentheses like with circles, we just know our center, H is going to be 0, so is K, so our center is at the origin. Go ahead and graph that. To determine the direction of the major axis, we look at the denominator. So 64 is the larger of the two numbers. Remember from yesterday I said a squared will always be the larger number. So this tells us that a squared is 64, which means a is 8. B squared will then be 36, which means b is 6. And because a squared is first, our ellipse has a horizontal major axis. So this means I will be counting 8 to the right and 8 to the left. That's from this first green point over to the other. That would be the length of our major axis. Our minor axis is going to go up 6 and then down 6. And then we can go ahead and draw in our ellipse. All right, so it looks like that. Plotting in the vertices at the end of our major axis, we have a -8, 0, and then an 8, 0. The end of our minor axis, which goes from the center, that's the shorter length that's here. So this would be 0, 6, and then over here, 0, -6. So our major axis runs horizontally here. It has a length of, it's 2 times a unit. So remember again, this is a units from the center over to the vertex, and then another a units from the center over to this vertex. So the major axis has a length of 2 times a, which is 8. So we have 16 units. Just to go back over, B would be the length from the center up here. Also another length of B here. So I'm not going to write this for every answer, but just to go back over, the minor axis will have a length of 2 times B, which is 6. So it is 12 units. So be prepared if I ask either one, major, minor axis, both of them, you understand what those mean. All right, for B, like A, we have a center at 0, 0, because we don't have anything else up here with the x squared and y squared. Okay, 49 is a larger number, so this tells me a squared is equal to 49. So a is 7, and b squared is 16, so b is 4. So again, center at 0, 0. Because the 49 is a larger number, it's second. Our ellipse will have a major axis that runs vertically here. So I'm going to count 7 up and then 7 down. I'm going to count 4 to the right and 4 to the left. And then go ahead and draw the ellipse through this. Okay, the vertices at the end of the major axis, this would be 0, 7, 0, -7. For the minor axis, this would be 4, 0. and then negative 4, 0. And the length of the major axis, again, it runs from center up to this vertex, so that has a length of 7. Down here has a length of 7, so we get 2 times A with 2 times 7, 14 units. All right, C and D are both very similar because now our centers are no longer at the origin. If you notice, we have numbers inside with the quantity here. So again, like a circle, we take the opposite. So our H is going to be negative 7, and our K is going to be a positive 5. So we have a center at negative 7, 5. Like B, the 25 is our second denominator, so this tells us that A squared is 25, which means A is 5. B squared is 4, so B is 2. So now I have a center at negative 7, 5. Because the 25 is our second denominator, I have an ellipse again where the major axis runs vertical. So I'm going to count up 5 and then down 5. My major axis will run through those. My minor axis is going to be formed by going 2 to the right and 2 to the left. And we will draw our ellipse now. Writing in each vertex. So at the top and the bottom here, this would be at negative 7, 0. And then this will be at negative 7, 10. Over here on the sides, this is giving us a negative 5. And then we'll have 5. And then over here, we have a negative 9, 5. Looking at the length of the major axis, again, I'm counting 5 up from the center, 5 down from the center, so I have a length of 10. All right, looking at D, also looks very similar, a center that's not at the origin. And just to let you know, if you didn't already try graphing this, the center is going to actually be at 3, 8. So if you notice, I adjusted my graph in order to fit this on the coordinate plane here. We have 100 is in our second denominator, so that tells me A squared is 100. Again, another vertical ellipse, meaning our major axis runs vertically, so A is 10. And then B squared is 9, so B is 3. So my center is at 3, 8. Plotting this right here. For my major axis, I have to count up 10 at the very top and then down 10 at the very bottom. I will be counting 3 to the right and then 3 to the left. And again, try to draw this by hand as best you can. Remember, you can always check on Desmos or your calculator what you did by hand that way. All right, looking at our vertices here at the very top and bottom. At the bottom here, we're counting over 3 down 2, so we have 3, negative 2. At the top, count carefully, but this should give us 3, 18 off to each side. This one here, we are up, should be at 8. So we are at 0, 8. And then over here, should be at 6, 8. And the length of our major axis. Again, we have 10 going from the center up to the top, 10 at the bottom here, so we should have 20 units for the length of our major axis. All right, so 1A and B were very similar. C and D were very similar. Now let's take a look at E. This one is a lot like our last example from yesterday. It's not quite in that HK form, and you'll see in a little bit, we are going to see something that looks like this with extra X and Y terms. This doesn't have that, but I do want to get this to be a 1, so I want to divide everything up here by 144. Now, most of the time, these two numbers that are the coefficients here tend to multiply to give us this. So you're going to see this, the same numbers sort of repeat here. But 144 divided by 9, or 9 goes into 144 16 times. So then this will become x squared over 16, because a 9 becomes a 1, and 9 goes into 144 16 times. So the opposite would happen here. We would get a y squared over 9, because 16 times 9 is 144. Then this gives us a 1. Good news here is our center is back at the origin, and 16 is first, so that tells me a squared is 16 and a is 4. B squared is then 9, so b is 3. So I have a center at the origin. Because a squared is first, I'm going to have a major axis that runs horizontally, so I'm going to count 4 to the right and 4 to the left. I'm going to count 3 up and 3 down. If you remember how I said a circle is a special type of an ellipse, these are pretty close. So the ellipse that we're going to draw is going to look almost like a circle. It would be exactly a circle if both A and B are the same, and that's the unique case with the circle. So drawing the ellipse now through these, pretty close to a circle. And the length of our major axis, as we write in the vertices as well. So we have 4 over here, 4 over here. So just writing in this vertex would be 4, 0, negative 4, 0. This would have a length of 8, 2 times 4. And up here we have 0, 3. And 0, negative 3, the two vertices at the end of the minor axis running this way. All right, so those were the homework solutions. Again, I hope you guys found, even if you had questions yesterday, maybe going over these solutions to be more helpful. So let's take a look now at how to go from general form to HK form by completing the square. So just as we did with the parabolas, you're going to see that we're going to factor a number out, keep everything for the most part on one side. It's going to be like a combination of a circle. We want to get our constants to the other side though. So the very first thing we want to do is keep our x's together. So I'm going to have a 9x squared minus the 18x. And then I'm not going to leave a space just yet because I have to factor some things out. So next I want to put my y's together. So plus 4y squared plus 16y. And then I want to move the 11 to the other side because we want to be able, like a circle, to see what we need to divide by at the end. Next, I'm going to look at these two, and not the x's, just the number. They have a 9 in common, so I'm going to factor out a 9. We're going to have x squared minus 2x. Next, I'm going to leave a space. Then I'm going to do the same thing here, just the numbers. I want to factor out what they have in common. Keep the plus sign. I'm going to factor out a 4. Then I'm going to have a y squared plus 4y and leave a little bit of space. And then after the 11, what we add to the left side, we'll add back to the right side. So I'm going to complete the square. So again, half of 2 is 1. 1 squared is 1, so I'm going to add a 1. Now I didn't just add a 1 here. I added a 1 times a 9, so I'm going to have to add a 9 to this side. After the 4 here, the 4y, half of 4 is 2, 2 squared is 4, so I'm going to add a 4 inside the parentheses, but I really added a 4 times 4, so I added a 16, so I want to add a 16 over here. So my next step now is I'm going to keep the 9 out in front, and then I write this quantity as x minus 1 squared, leave the 4 out in front. We're going to have a y plus 2 squared. Combine these numbers, 11 and 9 is 20, 20 and 16 will give me 36. So now we're kind of like the very last example, E. I'm very close, but I don't see a fraction, and I need to get a 1 at the very end here. So in order to do that, we're going to divide everything up here by 36. When we do this, Now we're going to end up, 9 goes into 36, so we get an x minus 1 squared over 4, plus 4 goes into 36, so we get a y plus 2 squared over 9 equals 1. Now here's our HK form of our ellipse. So we're going to graph this 2. Let's identify the center. So the center here is 1, negative 2. Just like what your homework was over, a squared is a larger number. So a squared is 9, making a 3. B squared is 4, so B is 2. So my center is at 1, negative 2. Because a squared, the larger number, is the second denominator, we're going to have an ellipse where the major axis is vertical. So this means I'm going to count up 3 and down 3. And then I'm going to count 2 to the right and 2 to the left, and then draw our ellipse. All right, so we determine the coordinates of the center, and then we'll also state the length of the major axis. Now for these, I'm not going to write each vertex in. We'll look at an example at the end, actually. So after having drawn this, we could write out that the length of the major axis, again, it's going to run from the center, 3 up, 3 down, so it's going to be 6. So we get 2 times 3, 6 units. All right, one more, we're going to complete the square. If you want to pause the video now and try it on your own, that's fine. Use last example to help you. If not, just go ahead and let this play and walk through this with me. Like the last one, our very first step is to get the x terms together. So we have 4x squared minus 24x plus 25y squared plus 100y. And we'll get the 36 to the other side, so it'll become a negative 36. Okay, what I want to do next, looking at the first 2 terms only, I want to factor out a 4. That's leaving us with x squared minus 6x. Then I'll go back and complete the square, so leave a little bit of space. Next, we want a 25 if we're looking at these 2 terms. That'll leave us with the y squared plus a 4y, leave a little bit of space, and then negative 36. So going back to complete the square for the first set of parentheses, half of 6 is 3, 3 squared is 9. But what did I really add to this side? If you said 36, you're right, because it's 9 times 4, so I need to add a 36. Over here after the 4, again, half of 4 is 2, 2 squared is 4, but what did I really add? 4 times 25, we added a 100, so we're going to add a 100 to this side. All right, next is where we want to factor this, so we still leave the 4, x minus 3, that quantity squared, plus, still keep the 25, y plus 2, that quantity squared. Combining these, the 36 is canceled, so we're just left with 100. Now, some of these problems do work out where these 2 leading coefficients here don't divide nicely by the 100 or aren't factors of it, but we're not going to be working on those, but I will tell you that they exist. So most of our problems that you will see, this 4 times that 25, again, most of the time will give us this 100 here. So now our next step is to go through and divide everything up there by 100. And then simplifying this, and it'll turn into our HK form of the equation. So 4 goes into 100, so we're looking at x minus 3 squared over 25, because 4 goes into 125 times. 25 goes into 104 times, so up here we end up with y plus 2 squared over 4 equals 1. Looking at our center is 3 from here. Again, we take like the opposite, and then a negative 2. A squared is a larger number, so a squared is 25, making a 5. B squared is 4, so B is 2. Because a squared is first, our ellipse will have a major axis that runs horizontally. So when I go to plot 3, negative 2, I'm going to count 5 units to the right, 5 units to the left. I'm going to count 2 units up, and 2 units down. Okay, so there's our ellipse. The length of the major axis, we have 5 units here, and then another 5 here. So our major axis is 2 times 5, which is 10 units. All right, so those 2 examples had us going through the entire process. First, we had to complete the square to get this in HK form, and then graphing this as well. Our next 2 examples are ellipses that are already graphed for us. So again, you can pause and make a sketch of this, but as you're doing it, what we need to look at first is the center, and then we need to know the lengths of A and B. Just like with writing an equation of a circle, we need the center and the radius. Well, because A and B are 2 separate radii, if you will, we need to find those. So if you pause this and you just want to look on your screen, you could do that, but identify the center and then the length of the major axis to help you find A, the length of the minor axis to help you find B. All right, so if we're looking at 3, our center is at 0, 3. Sometimes you still have to count the entire length of the major axis here. But if you put a point right here at 3, just to double check, we're counting up 1, 2, 3, 4, 5, 6. Look down below, 1, 2, 3, 4, 5, 6. So that actually helped us. So right now, we're going to say our center is at 0, 3. And counting up gave us A. Because the entire length of our major axis, we had 6 here and 6 here, so it's 12. So A is 6, and then B, we count over all the way here, but we just need half of that. So B from here to here, I'll highlight that in another color. This is B, and B is equal to 4. All right, so to write this equation, just to kind of get the template, it's a fraction, 2 fractions actually, separated by a plus sign, and we know it's always going to equal 1. Now our center and our numerators, we know it's always a quantity involving x as our first numerator, and then y is our second numerator. So because h is 0, this is just going to give me an x minus 0 squared, or x squared. But then next we're going to have a y minus k, so y minus 3 squared. Since our major axis is vertical, that means a squared, if a is 6, a squared is 36, that's going to be our second denominator. So there's our 36. And then b squared is 4 squared is 16, so that's going to be our first denominator. And then here's our equation. We get x squared over 16 plus the quantity y minus 3 squared over 36 equals 1. How can you check? That's right, Desmos or your graphing calculator. You could type this in and see if it graphs this ellipse that you were given. Double check the center, the length of the major and minor axis. All right, so if you didn't pause it already, pause it again for 4. Do the same thing, figure out the center, the length of A and B from the major and minor axes, and then continue to play to check this. So here our center, if we count again throughout the middle, the major axis here, its length is going to be 10. So if we just went over 5 from the one vertex here, we're at 4, negative 5. So our center is 4, negative 5. Our major axis runs horizontally here, so from here to here is A, so that's going to give me 5. So A is 5. And then B is right here of just 2. Again, I'm going to write out just 2 fractions equaling 1. Because this is horizontally, the major axis runs horizontally, that A squared will become 25. That's going to go first. And then B squared is 4. That's going to go second. What goes in the numerator again, guys? Our center. So notice we have 2 non-zero values here. So in our first numerator, we're going to have an x minus a 4 squared, and then a y plus 5 squared. And then there's our equation right here and here for these next two examples. All right, when I go to our last example, I want you guys to pause it, read it, and see what you come up with. Notice I have a coordinate plane here, so it might be helpful just to plot some of the points and see what you're coming up with. But all I'm asking you to do is find the center of an ellipse that has these vertices here and a major axis of length 10 units. So go ahead and pause it, give it a try to find the center. All right, so what we could do, now we may need all this information, we might not. I'm just going to go ahead and plot -1, -3, and then 5, -3. Now this tells us that our major axis is 10 units, but if I counted from this vertex here at -1, -3, and 5, -3, clearly that's not a length of 10 units, so that's really our minor axis. But is this enough to find our center? If we were to count in the middle, this actually has a length of 6, so if I just went over 3, that's going to mark our center. If you wanted to, you could still count up 5, and then down 5, but knowing the length of the major axis really wasn't necessary for this. All we had to do was plot our two vertices, and then knowing that it wasn't 10, that wasn't the minor, or that we were looking at the minor axis here, and all we had to do was go right in the middle of it. So our center is at 2, -3. And I'm just going to draw on the ellipse just to complete it here. All right, let me plug in because I'm losing some battery life. All right, and that was our last example. So your assignment is to finish the ellipse worksheet from yesterday, problems 3 and 4. Just to go back over it, I have it posted separately. But 3, A, B, and C all give you graphs. Count carefully to find the center to help you write the equation, just as we did with examples 3 and 4. And then on the very back, number 4, you have 3 examples there, 3 problems that you're going to have to get in HK form. You do not have to graph those. It just says for each ellipse, determine the coordinates of the center, the endpoints of both axes. So to help you identify the endpoints of both axes, it might be necessary to graph, but if you think you could figure it out a different way, go ahead and give that a try, and I'll explain it tomorrow as we go over these. As always, let me know if you guys have any questions.